The Stackelberg model is a prominent game theory model used in oligopoly theory to analyze markets where firms make decisions sequentially, rather than simultaneously. It was developed by German economist Heinrich Freiherr von Stackelberg in 1934 and is a crucial contrast to the Cournot model. 1. Game theory fundamentals in Stackelberg duopoly. In the Stackelberg model, the game is characterized by players, typically two firms, a leader, firm 1, and a follower, firm 2. Though it can be extended to multiple followers. Actions, strategies. Each firm chooses a quantity of output, Q_1 for the leader, Q_2 for the follower. Payoffs. Each firm's payoff is its profit, which depends on its own output and the output of the other firm. Information. Both firms have complete information about the market demand, their own cost structures, and their rivals' cost structure. The crucial difference from Cournot is the sequential nature of moves. The follower observes the leader's decision before making its own. 2. The key assumption, sequential decision-making. The defining feature of the Stackelberg model is that one firm, the leader, moves first, committing to an output level, and then the other firm, the follower, observes this decision and chooses its own output level in response. Intuition. Imagine two tech giants developing a new smartphone. One company, the leader, announces its new model specifications and production volume first. The other company, the follower, then takes this information into account when designing and launching its competing product. The leader knows the follower will react optimally to its move. 3. Solving the Stackelberg model, backward induction. The Stackelberg model is solved using backward induction, a standard technique in sequential games. 1. Solve the follower's problem, last mover. The follower, firm 2, takes the leader's output, Q_1, as given. It then maximizes its own profit, treating Q_1 as a constant. This process yields the follower's reaction function, or best response function, Q_2 equals R_2, Q_1. This function tells us the follower's optimal quantity for any given quantity produced by the leader. Intuition. The follower thinks, okay, the leader has decided to make X units. Given that, what's the best number of units I can make to maximize my profit? 2. Solve the leader's problem, first mover. The leader, firm 1, understands that the follower is rational and will always choose its quantity according to its reaction function R_2, Q_1. Therefore, the leader incorporates the follower's reaction function directly into its own profit maximization problem. When the leader calculates its profit, it substitutes R_2, Q_1, for Q_2. The leader then chooses Q_1 to maximize its profit, knowing exactly how the follower will respond. Intuition. The leader thinks, if I make X units, I know the follower will react by making Y units, where Y is determined by the follower's reaction function. So, I'll pick the X that makes my profit highest, knowing how the follower will adjust. 4. Stackelberg equilibrium, subgame perfect Nash equilibrium. The solution obtained through backward induction is a subgame perfect Nash equilibrium, SPNE. This is a stronger concept than a simple Nash equilibrium, as it requires that the strategies chosen constitute a Nash equilibrium in every subgame of the larger game. In the Stackelberg model, this ensures that the follower's response is always optimal given the leader's choice, and the leader's choice is optimal given the follower's optimal response. 5. Key outcomes and first mover advantage. The Stackelberg model typically yields distinct outcomes compared to the Cournot model. Leader's advantage. The leader usually produces a larger quantity and earns higher profits than it would in a Cournot equilibrium, and higher profits than the follower. This is known as the first mover advantage. Intuition. By moving first and committing to a large output, the leader effectively signals to the follower that the market has less residual demand left. The follower, being rational, will then scale back its own production to avoid driving the price too low, thus leaving more room and profit for the leader. Follower's disadvantage. The follower produces a smaller quantity and earns lower profits than it would in a Cournot equilibrium. Total output. The total industry output in a Stackelberg duopoly is generally higher than in a Cournot duopoly, but still lower than under perfect competition. Market price. Consequently, the market price in a Stackelberg duopoly is generally lower than in a Cournot duopoly, but still higher than under perfect competition. 6. Relevance and applications. The Stackelberg model is highly relevant for analyzing industries where one firm is genuinely dominant. It has a significant market share, technological lead, or established reputation that allows it to commit to a strategy first. E.g., a major airline setting flight schedules, a dominant tech company launching a new product standard. Sequential decision-making is realistic. Investment decisions, capacity expansions, or product launches often happen sequentially, with one firm making a move that others then react to. Commitment is possible. The leader's initial decision must be credible and observable by the follower. If the leader could easily change its mind after the follower makes its move, the first mover advantage might disappear. 7. Criticisms and limitations. While powerful, the Stackelberg model also has limitations. Assuming a leader and follower, the model assumes which firm is the leader and which is the follower. In many real-world scenarios, this might not be clear, or firms might strategically try to establish themselves as leaders. Credibility of commitment. The leader's commitment to its initial output must be credible. If the follower believes the leader might reduce its output later, the follower's reaction could change. Perfect information. The model assumes the follower has perfect information about the leader's output and that both firms know each other's cost structures and the market demand. Static nature. Like Cournot, the basic Stackelberg model is a static, one-shot game. In reality, firms interact repeatedly, which can lead to more complex strategies like reputation building or collusion. Quantity versus price. The basic model assumes quantity competition. If firms compete on price, the dynamics would be different, though Stackelberg versions of price competition can also be analyzed. Stackelberg versus Cournot. A key distinction. The main difference lies in the timing of decisions. Cournot. Simultaneous moves. Each firm assumes the other's quantity is fixed. Stackelberg. Sequential moves. The leader moves first, anticipating and incorporating the follower's reaction function into its own decision. This difference in timing fundamentally alters the strategic interaction and the equilibrium outcome, giving a clear advantage to the first mover in the Stackelberg scenario.